Hello guys, Code Purpose here. We are going on with our 17th exercise in our series of tutorials. In this exercise, the name of the exercise is Ciel and Receipt. So there is a girl named Tomia who loves Chief Seal very much, and there's a menu at this person's restaurant, this chef restaurant, where the prices are multiples of 2 factors. Multiples of 2: 1, 2, 4, 16, 32. That's 2 to the some power. Here we have the explanation that is 2 to the I minus 1 power. I'm going fast just to skip that boring reading of the text and focus more on the explanation. So we read t cases, and in each t case we read an integer p, which is represents the number of monies that has this girl Tamia, and she needs to eat least. So we need to get the minimum products menus that she can eat with that money. For example, if she has 2048 money, so currency, that's not important, she could buy 2048 of the menu with price 1, or she could buy only one with the price of 2048, and this is the minimum and that would be the maximum. So we need to find the minimum. Firstly, we have the number of t cases t, and then the number of the money p. We read the number of t cases, and for the exercise needs, I'm going to get an helping array named prices, and in this array we had, in the menu there, we have 12 different menus that were multiple of 2's. So I will initialize this array with the multiples of 2: 16, 32, 74, 128, 156, and so on until we reach 2048 as the 11th element of the array. This initialization of the array goes like this: the first one goes to the prices of 0, the fourth one goes to the prices of 3, and the last one goes to the last element of the array, which is in this case 12 minus 1, and that's prices of 11. And next we have the 4, which iterates t time the number of test cases from 0 to t minus 1, and in each test case at the beginning we need to read the number of the monies we Tamia has, the girl in the exercise, and we need a counter which at the start is 0, how many menus she could buy minimally, and we have a while the monies are different than 0. We are going in this. We are starting from the biggest price and checking if we can buy with that price something. If we can buy with that price something, we can divide by that, and the result would be the number of products that we can buy with that price. So I get another helping variable which is age, and it starts from 11, last element of the array, because we need the minimum number of menus, and so we need to start from the biggest price and so on until we reach the lowest one. And so the counter will be to the counter will be added uh, p divided by prices of h. So if this girl had 5,000 euro, for example, and we divide it with this, we get 2. We can buy 2 menus of 2048. And how many, that 2 is added to the counter, and the counter becomes 2. And how many money is left there? The remainder, while dividing by 2, is the number of the leftover money. So we have p modulus prices of h. And also, because we finished our job with our last element, we are going on with our next one, decreasing the h to 10, 9, until we reach 1. And as for AND, we just output the counter and new line. So let's test that test case that was there. It had 4 test cases. For the number 10, we get 2. For 256, we have 255. 256 is 1 because that price is here. 255 is 8. 4096 is 2 because it's 2 multiplied by 2048. Let's copy this and submit there. And while we are waiting for confirmation that the exercise is solved correctly, if it's solved correctly, I'm going to talk about another perspective of how we can solve the exercise. Because the numbers of multiple of or never mind. Let's just wait for the result. Don't make the video longer because I know that's bored. How longer it gets, it's more bored and bored because everyone wants to finish it as faster as possible. Thanks for watching. That's all about this video. Make sure to subscribe by clicking the red button right below the like button. You can also turn on the notifications by clicking the notification bell to not miss the upcoming videos. See you soon on Code Purpose.